Hello, everyone. So we have another 25 on the 10B. So we have a circle of radius of 1, okay, which is this one. Internal tangent 2 circles of radius of 2 at A and B. So this is the center of this circle, which has the radius of 2, and then B is the radius of the other one, as the center of B. And AB is the diameter of the smaller one. So if you connect this, that's the diameter. And we are looking for that shaded region. So this is another funky region, right? So we just like to start with finding some intersection and connecting those to get some like ways to get the areas and subtract or add some region that we can get to get what we want, okay? So that's kind of main approach that we use for the funky region. And if you never try this question, please like pause and go ahead and try and see if you can get something before you see at least a solution. But now I'm assuming you just did it, so I'm gonna just do on my own. Okay, so if I connect these, so that is my diameter, and I like to get this shaded region plus the shaded region, and I do know this is one intersection of two identical circles, and this is my center of the smaller one. If I connect these, right? So I can maybe connect all the way to the other side. So if I do that, so, you know, the shaded region is actually divided into two equal region, this part and this part, the same on this left side. So if you like find one of these somehow, then the rest is just gonna be just multiplied by 4, right? So then what we can do is just like write a few other information. These are 1 as well. And I do know this is 2, right? So if I take this center B and connect this intersection, so that will actually help us a lot, because if you do this, this is actually 2 units, right? And this angle right here is 90 degrees. Since this is 1 and this is 2, this is 2 because this is radius of the circle, and this is 1. So there is a 1:2 ratio, which is a 36 to 90 triangle, right? So that will give us the angle that is opposite to the one is 30 degrees. So, and then the angle, the other one has to be 60 degrees. And that side, if I name this is, I'll say T, let's say this is K. So TK, so T to K is equal to square root of 3, because that's 36 to 90 triangle, or you can just use the Pythagorean. So that's root 3. And but this is still does not really look like we are gonna get something nicer without really having something else. So, you know, what I need is, I'm gonna shade in a different color. Like my goal is to get this region first. If I find this region, then I will multiply that region by 4 to get our final answer. So, but if you look at the figure carefully that I have drawn so far, so this is actually can be like can be received by taking the area of this sector. So if you take this center B, because that's like part of this circle, right? If you take the center, and this is a sector, and if you subtract the area of this like quarter circle and this triangle, then this is gonna give us this purple region. So then that region, I will say, like purple region, is equal to the area of the sector, which is 60 degrees, which is 1/6 of the full circle, times pi times radius. Radius is just 2 units, so 2 squared, minus area of this quarter circle, which is 1/4, times pi times 1 squared, and then area of this triangle. So minus 1/2 times, this is 1 unit, this is root 3. So that should be root 3. And that's gonna be one of the region that we are looking for. And then we are gonna multiply this by 4. So that will be 4/6, which is 2 pi over 3. And then this is pi 4. and then minus root 3 over 2. So this is the purple region right here. Again, as I mentioned, this is the same as this part, and then we have 2 copies right here. So if you multiply this by 4, then the whole region is gonna give us the 8 pi over 3 minus just pi minus 2 root 3, right? So that will give us 5/3 pi minus 2 root 3, okay? So that's the choice B. So the question wasn't too challenging, to be honest. It's just hard to see how we can get that like funky region. So the way that I do was I connect the center of the small circle to some intersection to see if there's a way to get a region that we can get, so we can get what we want. And another thing that we just discovered was this triangle was a 30-60 triangle because the ratio is 1 to 2. So the 30-60-90 is always useful. So if you like more practice, go for it. But that was kind of main point of this problem. As soon as you discover that, so that's just subtraction of 2 regions. So the region that we subtract was first, like I did have this quarter circle, right? So which is just this region. And then we also subtracted the triangle right here. So if you subtract the triangle and quarter circle from the sector, so which what we did, that's gonna give us one of those 4 equal shaded region. So, and then we just multiply by 4 to get what we want. So I hope that was clear. I'll see you in the next video.